This week, we'll take a deeper look at portfolio optimization, which is one of the most important founding stones of the area of finance known as investments. We are going to think about it from first principles basis. So, when we are making an investment, basically the amount of money that we have at our disposal is something that we know. What we do not know is that depending on how we allocate our funds across different assets, how much of the return that we are expected to get, right? So we want to think about this question about, given the characteristics of the different assets, how do we optimally allocate our money across these different assets? So we are going to be thinking about this problem in a simple case where we have got basically only one single period. So unlike the other discussions that we have had in the previous weeks where we were talking about money being received over multiple periods, we are going to be abstracting away from that. And we are going to just think about the problem in the context of one period, which means that there is some amount of money which we are investing at some initial time. And then this payoff is going to be attained at the end of the period. Now, we are going to study this problem using mean variance analysis method, which, as you recall from the previous week, implies that we are going to be assuming that the decision maker has preferences which are dependent on only the mean and the variance of the distribution. This is a useful starting point, and it allows us to actually understand a lot of important insights. And as you have seen last week as well, that this also serves as the foundation for capital asset pricing model, which is again one of the important models in finance. So it makes sense for us to take a more deeper look at these things. So let's think about it from again the basics. So what do we mean by asset? So an asset is an investment instrument that can be bought and sold. So suppose that one purchases an asset at time zero and sells it 1 year later. Remember, we are thinking about this problem in the context of only one period. So we are going to say that the total return R on this investment is given by the quotient x1 by x0, where x0 is the amount of money that was invested and x1 is the amount of money that was received. So we can define the rate of return as well based on this total return. So the rate of return in this context is going to be equal to x1 minus x0 divided by x0. So you can see from here that the relationship between the total return and the rate of return is that the rate of return R is given by capital R minus 1, right? So it's very easy to go back and forth between the rate of return and the total rate of return. Also, sometimes you'll see just the word return being used. So typically you'll have to understand it from the context, but in a lot of cases, it just means the rate of return. So something to keep in mind. Okay, let's consider one possibility that we did not have in our last week's discussion. So in real world, it's often possible to sell an asset that one does not own. Okay, and this goes by a phenomena called short selling, or in short, shorting the asset. So how does this work? So the idea is that one needs to borrow the asset from someone who owns it, and then sell this borrowed asset to someone else. Okay, and when you sell it, you receive an amount x0. Okay, at a later date, then you are going to actually repay the loan that you have taken from this person, right? The asset that you have borrowed, by purchasing back the asset, okay, for a different price, perhaps for x1, let us say, and then you return the asset to the lender. Okay, this is what is short selling in brief. Okay, so why would you do it? Well, if you think about it, you are basically receiving an amount x0, okay, and then you are later on, once you have to return the asset, you have to incur a cost of x1, right? So in short, you end up making a profit of x0 minus x1. Now, there are some other complications in real world that one has to keep in mind, such as, if there is some dividends that this asset actually had paid out, then you also have to pay the dividend to the person from whom you have borrowed this asset. You might have to often pay a fee to this person from whom you have borrowed an asset, and so on. We are going to look at some of those complications later on, but for now, let's just think about it in a very clean way, that these are the only two payments that you have to make, right? So if you make a profit of x0 minus x1, you make a positive profit if x0 is greater than x1. So what that means is that short selling is profitable if the asset price declines, right, for the asset you have shorted, right? That's the important takeaway. Now, short selling is considered risky, right? Not just in the sense that the amount of profit that you are going to get is uncertain, but in the sense that the amount of losses that you can suffer is huge, right? Why would you possibly suffer huge amounts of losses? So remember, if your profit is x0 minus x1, the amount of loss that you are getting as a result of this transaction is x1 minus x0, right? So for instance, remember that you have to actually repay back uh, the return back the asset that you have shorted, right? So you know the price at which you are buying, at which you are getting the asset and you're selling the asset in the initial period. So x0 is known. What you do not know is x1, right? And suppose the price of this asset actually goes up a lot, so that you end up spending a lot in order to buy it back, to return it to the original person from which you have borrowed the asset, then your loss would be very huge, right? And as a result of this danger, short selling is often prohibited in quite a lot of financial systems, and is also often avoided by individuals and institutions. However, short selling is, in fact, a real part of the world, as you would notice if you read the newspapers and also different movies related to the financial crisis, if you have seen some of them, right? So it makes sense to kind of like consider it. Okay. So we want to actually use the return formulas that we discussed to think about what's the rate of return that you would associate with short selling, right? This is just application of these concepts of rate of return, which you have been seeing since week 2, but to a new context. Okay, so what is going on in short selling? Basically, you're receiving X0 initially and you are paying X1 later, right? So this is different from the usual bonds that you have been kind of like doing, or like interest payments that you do, where basically kind of like, you give out money first and then you receive money later. So if we are to rewrite it in terms of our usual notation, what it means is that your initial outlay is minus X0 and the final receipt is minus x1, right? Why do we have the negatives? Because remember, whenever we do these things, we usually think of the cost as the outlay, right? So if you're receiving it, so then you have to look at the negative of that. And if you are paying later, then again, the receipt becomes negative. So the total return, if we go back and use this formula, remember x0 was the amount of money invested and x1 was the amount of money received. So here, instead, you'll have the return being minus x1 by x0. And so therefore, that's equal to x1 by x0, right? The two negatives cancel out. Let's just look at an example to understand these things in case, concrete numbers make more sense. So suppose that Rita has decided to short 100 shares of company Y. The stock is currently selling for 10 per share. Now, what that means is that Rita has to borrow 100 shares from someone, let's say her broker, and she sells these in the stock market and she ends up receiving 1,000. Why does she receive 1,000? Because she has selling 100 shares at a price of 10 per share. So if you multiply, you end up getting 1,000. Now, at the end of the first year, suppose that the price of share of company Y has dropped to 9. Now, Rita needs to purchase 100 shares, right, from the market, let us say, so that to return it to the broker, right? Remember, the part of the shorting is that you have to also, at the end of the period, you have to also return it back, the asset that you have borrowed, to the broker. So how much will it cost Rita to purchase this? So it will cost 100 into 9. And so therefore, she actually ends up incurring a cost of 900, and she's able to return this 100 shares to her broker. So as a result of all of these transactions, Rita ended up basically making a profit of 100. So because she received 1,000 rupees and then she has returned she had returned these 100 shares at a cost of 900. And so that's where you get a profit of 100. Now, if someone had done the usual transaction of actually purchasing 100 stocks at 10 per share and selling it 1 year later, then that person would have actually made a loss of 100, right? Compared to Rita, who actually shorted the stock. Why would that person make a loss of 100? Because it would have cost 1,000 to actually purchase it, and then the value of the stock actually is like 900 when the person is selling it. So therefore, the total return is 900 by 1,000, right? Using our usual formula here. And so therefore, that's equal to 0.9. And the rate of return, remember, which is capital R minus 1, is equal to minus 0.1, right? So this is This is the result that you had for the person who had actually purchased the stocks. And when you have shorting, this negative rate of return actually becomes something which is a positive profit, because the original investment, remember, is also negative, right? The original investment being here the amount of money that uh, Rita was getting by actually selling these shares, right? So remember, she got 1,000 initially. So that's from her perspective, it's a outflow of minus 1,000, right? So minus 1,000 multiplied by minus 0.1. So that's the 100 that you see here. Okay, so let's now kind of get back to the portfolio optimization problem. So suppose that there are n assets that are available, and we want to form a portfolio of these n assets. What that means is that we want to divide the initial amount of money that we have, x0, among these n assets, right? So suppose that that means that we are basically selecting how much of this x0 amount of money do we want to give across different assets. So suppose that x0i represents the amount of money that is invested in the ith asset. Now this x0i, there are going to be n of these, right? x01, x02, x0 n till up to x0n, right? What is the zero standing for? That's the period, the initial period. And the second I is standing for the amount that you're investing in asset I, right? So that's the I part. And X is the amount that you're investing. So clearly, this has to sum up 2x0. That's the first part. And the other thing is that if you allow for short selling, then as we have seen before, this x0i can be negative. Okay. And if short selling is not allowed, then all the x0i's are restricted to be non-negative. So that is something new that we are bringing in compared to last week. Remember where we were discussing about you have a certain amount of money, you were actually putting in a non-negative amount in both the risk-free asset and the risky asset. Here we are saying that actually you can put in a negative amount by short selling. Okay, we can also express the amount invested as a fraction of the total investment, so that you have got, we think about the weight of asset I in portfolio as WI, and that's going to be equal to X0I divided by X0. So X0 was the total amount of money that you had for investment. X0I uh, is the amount that you are investing in asset I, right? As you can see from here, we require that summation WI has to be equal to 1. How do you see that? Well, if you sum up both sides, you get summation XOI is equal to summation over I WI X0. X0 is a constant. You can take it out. Okay. And we know from here that summation X0I is equal to X0. So from there, you end up getting that summation WI is equal to 1. Okay. And because of shorting, some of these WIs can be negative if you allow for short selling. If you do not allow for short selling, then these WIs have to be greater than equal to 0. Okay, so let RI denote the total return of asset I. So then the total amount of money that is generated at the end of the period by the ith asset is given by RI multiplied by XOI, right? Again, how do we see this? Go back to the definition in case things ever seem confusing. Remember, this R is the total return, X0 is the amount of money that you have put in, and X1 is the amount of money you are getting out, right? So what we are saying is that initially, if you had put in X0I and this asset is giving total return of RI, then the amount of money you are going to get is X1I is equal to RI multiplied by X0I. Okay, so that's how we get this expression here. And as we know, X0I is equal to WI is equal to X0. So we can write this also in terms of the weights of the different assets in the portfolio, right? So this is the expression. Now, this is the amount of money that is generated by the ith asset. We can actually now look up about what's the total amount of money generated by the portfolio. So we have to add up over all the assets. So we add up this expression that you see here for all the different i's. And so therefore, the total return of the portfolio there is equal to the initial amount of money that you had. And in the numerator, you have the total amount of money that is generated, right? And this is the total return, right? So if you see from here, the X0 you can take out of the summation because it does not depend on I. And so therefore, the X0 in the numerator and the X0 in the denominator cancels out. And so you end up getting that capital R is going to be equal to summation over I WI capital RI, right? So basically, the total return is of the portfolio is the weighted average of the returns of the different assets, where the weights are basically the weights of these assets in the portfolio. Okay, we can also do the similar expression for the rate of return instead of the total return. Remember that the relationship between the total rate of return and the rate of return is given by this expression here. And we know that the total rate of return from here is equal to summation over IWI RI. So that's the second equality that you see here. And this capital RI, we can rewrite it in terms of 1 plus small ri, where small ri is the rate of return of the ith asset. Now, if we do the summation, the first term becomes summation over IWI, and we know from before that that's equal to 1. So we can replace that by 1 here. And the second term ends up becoming summation over IWI smaller I, right? Now, if we cancel the 1 from here and here, we end up getting that small r is equal to summation over IWI times smaller I, right? So what you get is that the rate of return of the portfolio is equal to the weighted average of the rate of return of the individual assets, where again the weights are the same weights of the different assets in the portfolio, right? So this weighted average is true for both the total rate of return, as we saw here, as well as for the rate of return that you see here. Okay. All right, let's take an example to kind of like make sure that these ideas are fixed. That suppose that you have got 100 units of shares of company A, 400 units of shares of B, and 200 units of shares of company C in a portfolio. Okay, and the price per share of these different shares where the one for company A was 40, the one for company B was 20, and the one for company C was 20. Okay. So therefore, the total cost of assembling this portfolio is given by 100 into 40. So that's actually 1,000 into 4, so 4,000. 400 into 20, so that's 8,000. Plus 200 into 20, so that's again 4,000. And so therefore, the total cost is 16,000, out of which that was the total amount of money that you had that you allocated across these three different company shares. And so therefore, the weight of company A in your portfolio is given by 16,000. This is the denominator that you see in this expression. That's the total cost of assembling the portfolio. And in the numerator, you have 4,000, which is basically the amount of money spent on buying shares of company A, right? So that's 4,000 by 16,000. And so therefore, that's 25%. Similarly, you can do the calculations for company B and company C, and the weights turned out to be 50% and 25% respectively. Okay. Now, suppose that the rate of return of ABC are given by 10%, 15%, and 20% respectively, then we can use this formula that we have discussed to actually come up with what's the portfolio rate of return. So that's going to be given by 0.25 into 10% plus 0.5 into 15% plus 0.25 into 20%. Where are we getting these numbers? Well, remember, we calculated the weights as 25%, 50%, and 25%. So that's the 20.25, 0.5, and the 0.25 that you see here. And these are the individual assets rate of returns, the 10%, 15%, and 20%. So this is how we get this formula, and we are calculating basically this rate of return of the portfolio, which here, if you do the calculation, comes up to 15%. Okay, so why are we kind of like doing these things? Because we want to actually also link it to the discussion that we have about these portfolios and the randomness that is associated with it. So whenever you have randomness, we want to think of random variables. So what is the random variable that we would consider here? So this is the amount of money that is obtained when selling an asset, right? Remember our initial discussion, this is the part that is uncertain, right? We know how much money we have to allocate across different assets. That is the certain part. What we don't know is that how much is those investments going to be worth. That's the uncertain part. So whenever we have this uncertainty, we think about random variables. So let's just fix the general notation here and recap some basic concepts that we are going to be using. So suppose that X is a random variable, which can take on any one of these finite values, X1, X2 till Xn. And suppose that Pi is the probability that X takes a value Xi. Okay, so then we are going to say that the expected value of x is given by expectation of x, which is summation over I xi pi. And we are going to denote this expected value of x often by this notation x bar. We have also got the variance of the random variable x. So that's going to be given by variance of x equal to expectation of x minus x bar squared. So as usual, we are taking the deviations from the mean, squaring it up, and then taking the expected value of those. And we also denote the variance by this sigma square. And the standard deviation is the square root of variance. So that's the sigma. Okay. Now, we also have the two terms that we will see often this week, which is covariance and correlation. So let's just think about what are their definitions and how are they related to these concepts that we have discussed. So suppose that x1 and x2 are two random variables with expected values x1 bar and x2 bar, then the covariance of these variables is defined to be covariance of x1, x2, which is expectation of x1 minus x1 bar multiplied by x2 minus x2 bar, right? So basically take the product of all these things and take the expectation. And also you might know that this is the same as expectation of x1, x2 minus x1 bar, x2 bar. So I think those things are all things that you know from your basic statistics. So we would often actually denote this covariance of two random variables x1 and x2 by this notation sigma 1, 2. Okay. Now, if you think about it, what's the covariance of a variable with itself? That's nothing but the variance of that variable, right? So you can see that from here. So suppose that you were looking at covariance of x1 comma x1. So that would become expectation of x1 minus x1 bars square. And that's nothing but the variance of x1, right? So if you have got sigma xx, right, using this notation, that's the same thing as the variance. So sigma x square. Okay. And what's the relationship of this sum of variances with this variance and covariances? So if you have got x and y as random variables, then one can show that variance of x plus y is equal to variance of x plus variance of y plus 2 times covariance of xy. So I assume these things and the derivations of these things are all familiar to you from your basic courses in probability and statistics. Okay, we also have something called the correlation coefficient, which is nothing but the covariance divided by the product of the standard deviation of the different variables. And we are going to say that two random variables, x1 and x2, are said to be uncorrelated if you have got rho 1, 2 equal to 0, and which from here you also see that that's the same thing as saying that the covariance between the two variables is equal to 0. If you have got sigma 1, 2 is greater than 0, then because the denominator is also always positive, then you have got that the rho 1, 2 is also going to be positive. And we are going to say that the two variables are positively correlated. What this means is that if one variable is above its mean, then the other is also likely to be above its mean as well, right? And if you have got sigma 1, 2 to be less than 0, then the two variables are said to be negatively correlated, which means that if one variable is above its mean, the other is likely to be below its mean. Okay. There are also some relationships between this covariances and the standard deviations. So for instance, we know that the absolute value of the covariance has to be less than equal to the product of the standard deviations. That basically follows from the fact that the correlation coefficient is always less than 1, right? The absolute value of the correlation coefficient is less than 1. And often we would hear the term perfectly correlated. So that would correspond to the case where you have got sigma 1, 2 is equal to sigma 1 into sigma 2, which as you can see from here means rho 1, 2, the correlation coefficient is equal to 1. And if you have got sigma 1, 2 is equal to minus of sigma 1 into sigma 2, that would correspond to the case of perfect negative correlation. So all these terms I think are quite familiar to you from your previous classes. We are just recapping it because we are going to be using them extensively. And also we want to be familiar with the notation that we are going to be using.